10.9 is the last section in Unit 10, and it is really a review from what you did in Advanced Math 8 or in Math 1 last year, depending which class you came from. So a lot of this stuff is going to be review. And since fourth period is not going to have time to write down notes, what I want the substitute teacher to do is I'm going to leave this right here. By pressing the enter button, you can pause the video so students can write down the notes. Press enter now. Coming back to you. Now that they've written that down, there's only one other thing I want down in their notes. Please pause the video by pressing the enter button now so the students can write this down as well. And now here we go. So let's talk about what you wrote down. The three differences between linear functions, quadratic functions, and exponential functions, the graphs are going to be on the worksheets that I passed out to you. In front of you, you should have the Unit 9 Notes worksheet that has 10 problems and the Unit 9 worksheet, which has, I don't know how many problems, another 10 questions, I think? 11, one extra. So they're not really going to be asking you questions about their graphs, even though the graphs are something that you should kind of sort of know and pay attention to. The first thing that you should probably remember from last year's math class is that linear functions have a variable x in it. Not an x squared, not a 2 to the x, but they have an x like a y equals 2x or a 3x or 3x plus 7 or a x minus 2 or y equals, there's got to be an x in it somewhere, but not an x squared or not an x in the variable. Whereas quadratic functions have a variable squared in it. There might also be an x with that. And exponential functions have a variable x in the exponent. So the examples that they gave you some examples that look like y equals 3x plus 2. That's a linear function because it has just an x in it. For quadratic functions, they gave you something like a 2x squared minus 1. That's a quadratic. Exponential functions, they gave you 2 to the x power. The x is in the variable. So differences in the equation would produce a different graph. That's not the main idea here. The main idea is how are we going to be able to tell that a set of numbers is linear or quadratic or exponential? And that's where these things come into play. Linear functions have a common difference, meaning that the rate of change is the same in all of them. The rate of change is the same. Whereas quadratic functions have second differences. I'm going to give you an example of what that looks like on the notes worksheet. And then exponential functions have a common ratio. What does that mean? That means that they multiply instead of having the same difference, adding and subtracting. These ones multiply, and that's how we can tell. And so our major idea is, can you tell which one is which? The last thing we wrote down was there are going to be some tricky questions. When I was doing your worksheet, when I was making your answer keys, I was like, well, this is not a second difference. This isn't a common difference. This isn't a common ratio. It's not any of these three things. And then I realized, wait a second, it's neither. It's none of those three, and that was a possible answer. So if you ever get stuck like I did, make sure that you know that neither is a possible answer. You can say it's none of these. It's neither of these. That's what they're going to say. So this is what you have in front of you. You should have the Unit 10 Worksheet 9 notes. If they do not have that, then substitute teacher needs to pause the video and pass those things out if you haven't done so already. There's the three graphs. But the major idea comes right here on 1, 2, and 3. If you understand these three things, then everything else below it will make a whole lot of sense to you. If you have a list of numbers And the x's are going sequentially. They're in nice consecutive order. And you notice that the y value is adding 3 and adding 3 and adding 3. If the common difference is the same, this is changing by 3 every single time. The y values have a common difference of 3. A blank model fits the data. When the rate of change is the same, it's a linear model. There's your first answer to number 1. Number 2. If your x values are moving up sequentially in consecutive order, and you notice that you're multiplying by 2 and multiplying by 2 and multiplying by 2, you're multiplying by the same number. That's called a common ratio. Ratio, think multiplication. If values have a common ratio of 2, we wrote it down. Common ratio, exponential. Exponential. I guess they didn't take English. This should be an exponential model. Fits the data, right? An exponential, because that word starts with the letter E. Number 3. The second differences of the y values are all 4. Second differences, if you were wondering what the heck the second difference is, if you go, I'm subtracting, or let's see, I subtracted 2, then we added 2, then we added 6, then we added 10, and you notice that there's not a pattern there. But you then look at these numbers and say, if I'm adding 4 and adding 4 and adding 4, that's called a second difference. When you look at the first differences and you see that the differences between the first differences are the same, that means they have a common second difference. That is a quadratic model or quadratic function. So if we know that, then most everything else should make sense to us as we go through this worksheet. Sometimes you're going to have to graph. Sometimes you're going to be looking at a chart. So let's look at a graph. Let's do a couple of examples. It says graph each set of points. Which model is most appropriate for each set? Choose from linear, quadratic, or exponential. Now notice it says that you only have these 3 choices. So you plot 0, 0. Put your dot at 0, 0. You have a point at 1, 1. You go to the right 1, up 1. You put a dot. You put a dot at negative 1, negative 1 half, negative 1, negative 1 half. 2, 3. You go to the right 2, up 3. This is an interesting one, right? Like it's kind of doing this. They have only given you 4 points. Now, they did not give this to you in sequential order. If you think about it in sequential order, it goes negative 1, negative half, then it goes 0, 0, then it goes 1, 1, then it goes 2, 3. Now that's in sequential order with your x's, right? If you start looking at did I do something wrong? 0, 0, Mr. Paramo. 0, 0. There we go. If you start looking at your y values, do you see what's happening? Let's see. They've added 0.5. Then they added 1. Then they added 2. Well, that's not helping me. So is there a difference between the difference? If I add 0.5 and I add 1, that's not going to be the model. Are they multiplying by anything? If I do, are they multiplying by anything? Let's check that. Are they multiplying by 3? I might feel like I'm messing up somewhere. Am I? Erase this. They times this by 3. They times this by... you're not multiplying anything. This is where I go and see what I did before. What did I do? I wrote down exponential last time I did this. Now I'm trying to figure out mathematically how come I wrote exponential. Exponentials are supposed to have a common ratio, right? Why am I not thinking of it? What are we multiplying by? I don't know. I see an exponential graph. Okay. I'm getting distracted. I'm distracting myself. Let's try another one. 0, 11. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 11's the very top. 1, 1, 2, 3, 4, 5 is the next one. 2, 3, 3, 1, 2, 3, 4, 5, 3, 5. Kind of an interesting deal. Like if I were to connect these, kind of see this. This is kind of what I'm seeing with my graph. What kind of model do you say it is? Just based off of the graph, based off of what we can see up here. If you say quadratic, you are correct. So that's what I'm going to leave you with on number 6. Number 6, you're going to graph it and then you're going to choose what the model is. It should be pretty simple for you. And then we get to the 7, 8, 9, and 10. But I want you to notice that it says linear, quadratic, exponential, and then they throw in this extra word, or neither. Because sometimes it's none of the above. If it is none of the above, if it doesn't fit the model, then choose none of the above. So for example, look and see what they did to go from -3 to -1. They added 2. To go from -1 to 1, they've added 2. They've added 2. They've added 2. If you see a consistent rate of change, if they have a common difference, adding the same number, adding or subtracting for that matter, it is linear. If you then try the same technique, they added 1, they added 3, they've added 5, they've added 7, and it's not the same, it's not linear. But you should double check is there a second difference? Is the second difference the same? If it is, then it is a quadratic. And so I'm going to let you work on 9 and 10, but I hope that gives you an idea of what you're supposed to do. I need to think about number 4. I'm just drawing a blank because I'm doing a recording. But I'm going to give you the rest of the time until we get to quiz 2 to work on worksheet 9 notes and worksheet 9 homework. We'll stop your notes right there.